right, everybody, welcome back to the channel and welcome to today's video. In today's video, we'll be going over the most expensive filament that Bamboo has in their store, the PPA CF. I was able to get it on sale for $100, which is insane for 0.75 kilograms of this. So it's not even a full roll like we're used to with everything else. And I looked this morning and it's back to normal price of $150 a roll. So we'll definitely be taking a look at what the use cases would be for a filament like this before you shell out $150 for not quite a roll of it. We'll also go over how easy it is or not easy it is to take it right out of the box. I tell you, you definitely are going to need a game plan for this. So if this is something that you're using, I'll give you some hints and ideas on how you might do this in full production. We're just going to print a couple of things with it. I'm upgrading my CNC out in the wood shop. And there's some brackets and some different things that I would like to print out of this material to take advantage of like the, strength and quality of it and everything like that. So in today's video, we'll go over what the possible use cases are, what's so special about this filament, and then we'll get into pulling it out of the box and printing with it to see how hard or easy it is for that. So if all that sounds good, then sit back and relax and I'll get everything ready. All right, so here we are on Bamboo's website, and as you can see, $150 for it's not even quite a full roll like we're used to. It's 0.75, I think, on there. Yeah, 0.75 kg. So $150, super expensive. I think the main reason is these first two things here: metal-like strength, industrial grade precision, stable performance in humid conditions. So this is supposed to be one of the filaments that does not isn't as hydrophobic or whatever, or takes in water. That's why we have to dry all of these filaments, is because they take in water just from the air. But this one's supposed to do the least of it. Unmatched performance under high temperatures. You'll see there's a nozzle for like a hair dryer or something here. So if that's something that you're doing with like vinyl stickers or something like that, or there's several uses that you could use for that. This would be a filament that you would want to use for the high temperatures, and we'll see that everything about this is kind of hovers around these high temperatures, and that presents a problem in the first thing that we try to do with this. So 0.2 nozzle not compatible, hardened steel nozzle mandatory. You cannot run this through the AMSs, and it must be dried out before use to achieve optimal print quality. And this is where we're going to run into our first issue, is actually drying this. So let's take a look at what they recommend to dry this out, and I'll show you what I'm talking about. All right, so down here we'll see under the recommended printing settings, the drying settings, blast drying oven, 100 to 140 C for 8 to 12 hours. Nozzle temperature 280 to 310, bed temperature 100 to 120. So you'll see that everything is super high, but pay attention to this minimum of 100. Let's also go into the filament guide here and take a look at it. And we can select PPA CF, which is what we're using here. And under drying condition, blast drying oven 100 to 140 C, 8 to 12 hours. Within this range, a higher temp, a better drying result. X1 series printer heat bed 110 to 120 for 12 hours. Not as good as blast drying oven. So this is where I ran into the first issue, is I guess you can set the heat bed to this temperature and dry it for 12 hours. But if you do the drying filament, it only lets you get to 90 C in the X1 if you want to go through the drying filament thing where the whole internal thing is 90C. Here it's saying to just use the heat bed at 110 to 120 for 12 hours, but not as good as drying a blast oven. So here right away, if this is something that you're going to use a lot and for spending $150 a roll, I would imagine this is something that you're using for some sort of production or something like that, and you really, really need all of the characteristics of this filament. You really should look into blast drying ovens. So I looked at that, and I looked at a couple of different things that people have done there. So one of the things that people do is get a dehydrator. But from some of the things that I've read and seen, that's not maybe the best. I guess you could put this in your regular oven, but 110 to 120 C is only like 200 and something degrees Fahrenheit, which is, I'm not even sure that my oven goes down that low. And then you're using a giant oven for 12 hours to heat up your filament, which isn't very efficient unless you're drying like a whole bunch of rolls at a time. That would be good. So what I found, and we'll take a look at it here, is there's a guy on YouTube that did a DIY kind of, this thing will hold up to 4 rolls, and you can dry stuff at these higher temperatures and everything and control it, and then you're able to just print directly out of it. And I think that's probably going to be your best result, is you're going to have to do some sort of DIY, unless you're just doing a whole bunch of these, and you could, get an oven that'll do 200, 250 degrees or 110 to 120 C, and do that, because you're not going to be able to do it with the printer. It's not going to be efficient and effective. I did this at 90 C for about 18 hours, and then I put the filament in the S4 under the sustain. So it just sustains that, and then I'll print directly from the S4 here in a minute when we start printing things, since it doesn't go through the AMS. But you definitely need to have a game plan around just drying this filament. Although it is, the most moisture resistant filament, it still requires some drying, and you're going to need to come up with some way to do this. The X1, and we'll see here in a minute when we start printing with this, if this is going to be sufficient for mine. But again, if you're going to be doing a lot of this, I would not recommend just using the X1 to dry the filament. And the normal filament dryers are not going to get hot enough to fully dry this filament. You need to get it, I've read in a couple of different places for some of these, that you need to get it above 70 C for an extended period of time to really dry out this type of filament. So even the S4 or the eSun one that I have is just not going to be enough. It doesn't get hot enough to completely dry out this type of filament. So let me pull up this YouTube video so you guys can reference it on how to build one of these blast furnaces. All right, so here's the video I found by Mighty Studios. Make sure you go check him out. He has a ton of really cool videos on here. Does some really interesting things with 3D prints. So go over there and make sure you give him a subscribe and a like, definitely, on this little DIY creation that he did. But make sure you go over here and watch this easy high temp 3D printer filament dryer. And he goes over how to put one together that'll do up to 4 rolls. And he has a link to all of the stuff that you need to do this. And it's pretty easy. It's only like an 8-minute video. And this looks pretty easy to do. So if you're going to use this type of filament, or if you use filaments that require that high temp drying and you're using that a lot, take a look at this video, and you're probably going to need to come up with something like that. So make sure you come over here and smash the like button and give this guy a subscribe as well. And this is a really good way to dry your filament, and then you can print directly from this thing as well that he creates. So hopefully this helps. If you're going to use this type of filament a lot, this is going to be a must-have. All right, so now that we have the drying taken care of and have that out of the way, let's take a look at the other considerations that we need to look at. So as it stated in the beginning, no 0.2 nozzle. The 0.6 is recommended with most of the carbon fiber stuff. You'll see that the 0.6 is recommended. You see right there on the ABS glass fiber, even on the glass fiber ones. And the other thing is the smooth PEI plate, or what used to be called the high temp plate, or the textured PEI plate, which is what we'll use today. And it does recommend printing in an enclosure. So I have the roll in the Sunlu S4 dryer with the sustain on, and I went ahead and fed it into the X1C, and everything's ready to go on that. So let's go ahead and open up Bamboo Studio and see what we're going to print first. All right, so for our first print today, I recently upgraded my CNC system, and I'm putting things together, and one of the things that I did is I got a spindle for it, and as you can see, it has what's called a VFD, which is basically the controller for it. And there's a way that I can mount it to my current system underneath to keep it out of the way and be really cool. And what's really cool about Pwn CNC is they have all of these pages. If you click for makers right here, that have all of these files that you can download for all of their stuff for a couple of bucks. And I think even some of these dust collectors that require magnets and stuff, you can buy the magnets and the thread inserts and everything that you need. But what I need today is these VFD mounting brackets. So these go on the side of that VFD and easily let it mount it to my table that I have. So I've already purchased these and downloaded these and put them in Bamboo Studio. So let's open it up and take a look at it from there. All right, so here's the files loaded in Bamboo Studio, and I arranged them on the build plate here, and I changed it to the texture PEI plate. You'll see that now that I have it loaded in the manual thing, it has a number 9 here that I can select, which is pretty cool. And I went ahead and did that, and I just selected the material. And again, you can select any, if you just push the numbers on your keypad or whatever, that's what selects, whatever number is there. So like the red one is the number 2, white is number 3, and this particular one is on number 9. So you can see that I've done that. Click this one, push 9. Both of those have been selected with that PPA CF. So let's take a look at the settings out of the box. So this is, right out of the box what the settings are for the PPA CF. We're going to leave it alone and see how it prints. If we do run into issues, and if you run into issues, most likely you need to raise the temperature of this or raise the bed temperature of it as well. This is very, very dependent on the temperature, both of the drying and of what you're printing at, to get the best results. We'll also see that the max volumetric speed is 8, so this is going to print relatively slow compared to like your PLAs, I think, are 20 or 22 or whatever, and your 15-minute benchies and everything are going to be with a much higher max volumetric speed here. So we'll leave everything alone here. These are all the settings that come out of the box. Again, if we run into issues, the things that we'll want to take a look at are going to be the nozzle temperature as well as the bed temperature. Would be things that we would need to raise up if we run into problems. But we'll cross that bridge if we need to. So we'll leave all of that stuff alone. The one thing that I do want to change here, and not that this needs extra strength, but I just find if you change the sparse infill to 25, especially on some of these engineering filaments and even on your PLA filaments, it seems to print a little bit better quality or whatever. Sometimes on the 15% you can kind of see through. We probably won't on the black, but like on your white and your lighter color materials, you can see kind of the grid in the background there. And I guess you could change the walls and everything like that, but I like to change the density of the infill, and that kind of takes that part of it out, and it also makes it a lot stronger. And I don't think that we need the strength here, but we are going to change that just because we're printing brackets. Anytime you do brackets and stuff like that, make sure you change this infill and make it a little bit thicker. So let's see how long it's going to take to print with these. So 3.5 hours with the PPA CF, and let's go back and we'll change this to the normal PLA real fast, and with the same settings and everything, you can see it's an hour faster to do that, and the biggest reason why is the max volumetric speed. So just keep in mind that when you're printing with this, it's going to be very high temperature, and it's going to print at a much lower rate than other filaments that you're used to. So I'll go ahead and get this printed, and I'll see you when it gets done. And make sure when you go to print this that you deselect enable AMS so it knows that you're using the outside spool, or in my case, just running it from the S4. All right, so as you can see on the textured plate, without putting any glue or anything on there, 2 times I had it kind of fail on the print. But I did it on the high temperature plate, and it printed out perfectly on that. The quality of the print is really good. It does kind of have that rough texture like you get with other carbon fiber, right? It's smooth kind of on the build plate, but everywhere else it's a little bit rough. Now I did print this same model in PLA with the same 25% infill. So let's take a look at the weight difference between the two. So we know that there should be a significant strength difference between this one and this one, but I'm sure there's going to be a pretty big weight difference as well. So let's take a look at the PLA. And we have 131, 132 grams. Let's look at the PPA carbon fiber in 83 grams. So that's about 60% of the weight. So 40% weight reduction just in this thing here. And this has got to be way stronger than everything else. Now, when I printed this in PLA, it did have a little bit of warping on the ends here. When I printed it with this stuff, it printed perfectly, other than printing on the textured plate. So if you're planning on using this and putting it on the textured plate, you're probably going to need to do some further calibration and probably raise the bed temperature, or maybe try putting glue on here. But with the high temperature plate or the smooth PEI plate, this stuff printed perfectly first time right away, and you're able to do the flow calibration on that, so that kind of helps as well, I think. So this is a pretty niche filament here, although it did sell out pretty fast. I think within a couple of days. It looks like October 15th, in a couple of weeks, they're going to have some more. If you want to try some of this, it's super duper expensive, but if you do need the strength or the heat resistance or anything like that, this is definitely the way to go. The tips and tricks with this is you got to have a game plan for drying this filament out. And then I would have some sort of system that keeps it dry while you're printing. So I'll leave a link in the description below to the YouTube video that I showed with the DIY heat box. And if you're going to be printing a whole lot of this, that is what I would definitely recommend for that. Other than that, it looks like this is really cool. I'm going to print out all of the rest of the stuff that I need for my CNC machine out of this super expensive filament and see how that goes. But so far, I'm really, really impressed with it. And even with, putting a 25% infill, it's still relatively light compared to just normal PLA. So I hope you enjoyed today's video. And I'll print some more of this stuff and show it on the live stream. Be sure to join us on next week's live stream. I'll be giving away one of the Panda doors. So this Panda door, to be exact, brand new in the box. Send in your best print, and whoever gets the best print of the evening next Saturday will win this Panda door. So make sure that you send in your best print, even if you sent it in before. and next week somebody will take this panda door home. So thank you for watching. I hope everybody has a great rest of their week.